In this presentation, we will be presenting our paper on developing an anti-counterfeit system using blockchain technology. Our group consists of Anthony, Michael Christian Lee, and myself, Rafaelle Richel. To start this presentation, we will begin with the introduction part of the paper. We all know counterfeiting is undeniably a big problem in society right now. In 2020, about $1.5 billion worth of items were seized by the US Border Protection. Items that are seized most often are handbags, wallets, clothes, and footwear. This counterfeiting problem can be blamed on poor governance and loopholes that exist in the system and are exploited by counterfeiters. The items are then consumed by people who are incentivized to buy counterfeited goods because of how the internet reinforces the prestige that comes with using luxurious brands. But not everyone has the means to purchase genuine luxury items. These people will then resort to buying counterfeited goods. Our solution to the massive, never-ending counterfeiting problem is to utilize blockchain to create an anti-counterfeit system. Why is blockchain the answer to this problem? The biggest reasons are the fact that blockchain possesses four very crucial attributes that can help eliminate counterfeiting. These attributes are decentralization, which gives control to a distributed network instead of an individual; immutability, which means the system created with blockchain is tamper-proof and impossible to change without proper authentication; transparency, where users are able to view where the data came from and its transactions; and traceability, which means each chain blocks can be easily traced. Blockchain has been utilized in many different ways by many researchers. Here's how they have been doing it. They have been combining it with other technologies. We found research that deals with anti-counterfeiting using blockchain combined with other technologies like NFCs, QR codes, RFIDs, and even IoT to create synergy. They have also been applying it to many industries. During our research, we also found that blockchain is being used in many different industries, such as the medicine industry, which uses blockchain to trace medicine and vaccine files, the education industry, which creates certificates, and the retail industry, which uses blockchain to create a tracing system. Lastly, they have been creating decentralized and transparent systems using blockchain. With attributes that are prime for creating tracing systems, blockchain have been used to create many decentralized and transparent systems, like preventing counterfeiting with NFC technology for supply chains, and using blockchain and smart contracts to create a certificate system that can trace each certificate. Now, we will move on to the methodology part of the paper, where we will be discussing what the anti-counterfeit system will look like. The method that we will be using for this project is to use the Ethereum blockchain as the backend platform, and to use Solidity, which is an object-oriented language, to write the smart contracts used. There will be a user interface that is accessible to every user party, and Remix IDE will be used as the development tool. Now, what are blockchain and Ethereum? Blockchain is inherently a data ledger with unmodifiable properties that is able to record transactions and help with the traceability of assets within the business network. Blockchain works by generating blocks that contain different hashes that proves its identity. Each block is tightly linked with the previous block. To insert a new block, each block will be processed and verified by every single node in the chain in order to ensure the validity of the data inside the new block. Ethereum is a blockchain which utilizes a Turing-complete programming language that allows developers to create arbitrary, consensus-based applications using smart contracts due to its Turing-complete nature that supports a large set of computational instructions. Smart contracts are programs that execute automatically when the prerequisites contained in the program are met. With the data that the blockchain gets when the contracts have been executed, the system will store it and use the data to prevent counterfeiting activities. Our system will use role-based access control, which will have three roles with different rights and privileges. The roles are manufacturer, intermediaries, and consumers. By using smart contracts and RBAC, we can ensure data security by granting access and restrictions to users divided by roles automatically, without a third party. As you can see on the screen, each role will be able to interact with the system and with each other to complete their goals. This system works as follows. First, the manufacturer inputs data regarding a new product into the blockchain, such as the product ID, product name, etc. This data will then be recorded and stored into a Genesis block inside the blockchain. When the product is sent to the distributors or sellers to be sold, a transaction contract to create a new block and chain it to the previous block will be made. The source address will be the manufacturer's address, and the destination address will be the distributor's or seller's address. Before buying the product from the distributors or sellers, Consumers will be able to verify the product integrity by querying the product ID in our system. Our system will return information regarding the product such as its name, batch number, production date, shipment batch, and shipment date. Consumers can also check the history of the product and every transaction it has been through with the current owner's information. For further security, the consumer can ask for the seller address and verify it with our verification function. Our system will compare the address with the current owner address, which is not available to view by unauthorized users. If the function returns true, then the seller is verified and as the current product owner. This will guarantee that the customer is buying the product from its previous owner and not a clone product. After everything is verified, a new transaction contract between distributors or sellers and consumers will be made. This will chain another block into the blockchain and change the current owner address to the consumer's address. The dummy data used for our experiments are as follows. We made dummy data for user data and product data. The user data has a name, ID, and address. Each user is provided with 100 Ethereum for transaction purposes. The product data, on the other hand, have attributes like product ID, product name, batch, production date, shipment batch, shipment date, date received, receiver ID, and manufacturer. Results and discussion. In this section, we will explain the main function outputs of our anti-counterfeiting system, including the expenses needed for operating these transactions. On the screen, we can see three figures. The first figure shows the output when manufacturers created a new product to be shipped to a seller. Manufacturers must input product information like product ID and so on. This step has the highest execution cost because it creates new Genesis block inside the blockchain. Whenever the product switches owners, such as when the manufacturer ships it to the seller or when the seller sells the product to the customer, the transaction must be recorded into the blockchain as shown in Figure 2 and Figure 3. For product transfer from manufacturer to seller, the manufacturer needs to input the product ID and the seller ID as shown in Figure 2. But for the product transfer from seller to consumer, the seller needs to input the product ID, the seller ID, and the customer ID as shown in Figure 3. If there are any errors when recording the transaction, it will not be stored in the blockchain and our system will display an error message. Our system provides functions mainly for consumers to check the authenticity of products they want to buy by comparing the seller address with the current product owner's address recorded in the blockchain. The customer must input the product ID, seller ID, and seller's address to verify the authenticity of the product. As shown in Figure 1, the seller address given to the customer does not match the current product owner's address, therefore making the product the seller offers invalid and questionable. Figure 2 shows the customer can also receive a product's detailed information by querying its ID into our system. This will ensure no product switching. While Figure 3 shows that the consumer can also view the entire ownership history of the product using its ID. Another thing to note is that the consumer cannot see the ownership addresses, only their IDs. This guarantees that no one can impersonate the current owner by giving false addresses. To calculate the cost analysis of our model, we have to look at these two figures. Figure 1 shows how much GUI is needed when creating the first Genesis block of a product, averaging around 354,989 GUI for one product, while Figure 2 shows how much GUI is needed for executing an ownership exchange smart contract. The average GUI needed to change the ownership of an item is 180,028 GUI, therefore making the total average cost needed to counterfeit-proof a product undergoing 2 transfers of ownership using our system be around 715,046 GUI. In the last part of the paper, we will be discussing the conclusion we reached and the future work selection section of the paper. In this paper, we have proposed a blockchain-based anti-counterfeiting distribution system. This system will ensure that every product that exists within the system is an authentic one. In the end, we successfully developed this system using Remix IDE and Solidity. We have calculated that the average cost needed to operate the system is only 750,046 GUI per product with 2 ownership transfers. Therefore, we have proven that it is possible and viable to develop a system detecting counterfeits with minimal costs using blockchain. In the future, upscaling and improving our system will be possible, as our system is still a small-scale system and still relies on manual inputs. Automation can also be applied to ease the manual input process and reduce human error that may occur. Another factor that limits our system is the price of Ethereum. Our system is dependent on the price of Ethereum, and if it fluctuates too high, the cost of using our system will automatically be more expensive. And that is the end of our presentation. Thank you for listening and goodbye.